Today's topic is on applications to difference equations, and this topic is from Z transforms. And now in this video we are going to solve difference equations using Z transforms. That is y of k plus 2 minus 5y of k plus 1 plus 6 times of y of k is equal to 5 par k, where the given conditions are y0 is equal to 0 and y1 is equal to 0. So in order to solve this problem, so we have to consider, let z transform of y of k is equal to capital Y of z. And next, z transform of y of k plus 1 is equal to z times of y of z minus y naught. And next one, z transform of y of k plus 2 is equal to, this is z square times of, this is y of z minus y naught minus y1 by z. So these three conditions are given and we have to go with the given equations. What is the given equation? So the given equation is like that: y of k plus 2 minus 5y times of k plus 1 plus 6y of k is equal to 5 par k. Now we have to apply z transforms on both sides. So apply z transforms on both sides. So after applying z transforms on both sides, so what happens here, that is z transform of, see here, z transform of y of k plus 2 minus 5 times of, again z transform of y of, this is k plus 1 plus 6 times of z transform of z of y of k is equal to, here z transform of 5 par k. Clear? Z transform of 5 par k. And see, we have all the formulae ready here. So y of k plus 2 can be written as z square plus y of z minus y naught minus y1 by z. I am clearly writing here. So in place of this I am writing this one, that is z square into, this is z square into y of z minus y naught minus y1 by z. Clear? This is minus 5 times of, see here, z of y of k plus 1 can be written as z times of, this is y of z minus, this is y naught plus, this is 6 times of z of y of k is equal to, this is y of z. And z transform of 5 par k can be written as z by z minus 5. Since according to the special functions, z transform of a par n can be written as z by z minus a. So in place of a we have 5 and I wrote z by z minus 5. And clearly, so from the conditions, what are the conditions given? Y0 as 0 and y1 as, so y0 as 0 and y1 is equal to 0. Now I am substituting the conditions here. So what happens here? So this will be z square times of, this is y of z. What is y0? 0, and this is also 0. So what remains? Minus 5z times of, this is capital Y of z, y0 is 0 here, and 6 times of y of z is equal to, this is z by z minus 5. And now see, I am taking y of z common from this equation. See, y of z, if I take common, what remains? Y of z, if I take common, this will be z square minus 5z plus 6 is equal to z by, this is z minus 5. And so y of z can be written as, this is z by, this is z minus 5 and this is, so if I send this to other side, this is z square minus 5z plus 6. And if I send this z to other side, so this will be y of z by z is equal to 1 by, this is z minus 5. And if I split into fractions, see here, this will be z square minus 2z minus 3z plus 6. So if I take z common, this is z minus 2. If I take 3 common, this will be z minus 2. So this is z minus 2 into this is z minus 3. So in place of this one, I am writing z minus 2 into this is z minus 3. And see, now this can be written as y of z by z is equal to, this is z minus 2 into z minus 3 into this is z minus 5. And now I am going to resolve into partial fractions. According to the partial fractions, we have y of z by z is equal to, see, this is y of z by z is equal to a by z minus 2 plus b by z minus 3 plus c by this is z minus 5. Now I need the values of a, b and c. So for that, see here, 1 by this is z minus 2 into z minus 3 into z minus 5 is equal to, if I take LCM here, this will become z minus 2 into z minus 3 into this is z minus 5. This is a times of this is z minus 3 into this is z minus 5 plus b times of z minus 2 into this is z minus 5 plus c times of z minus 2 into this is z minus 3. Now I'll cancel the same denominators and the equation becomes 1 is equal to, so here 1 is equal to a times of this is z minus 3 into z minus 5 plus b times of z minus 2 into z plus z minus 5 and c times of z minus 2 into this is z minus 3. Now if I put, see here, if I put z is equal to 2, so this will become 0 and this will become 0. And what remains here? Then 1 is equal to, see here, our 1 value is equal to, so this is a times of 2 minus 3 into 2 minus 5. So a is equal to a times of this is minus 1 and this is minus 3. And a value is equal to a times of this is, so this is minus of minus plus 3 and a is equal to the value here is 1 by 3. Clear? So we got the value of a as 1 by 3. And next one, put z is equal to, put z is equal to 3. Now put z is equal to 3. So if you keep z is equal to 3, what happens here? So this will become 0 and this will become 0. And therefore, what remains? So 1 is equal to b times of, this is 3 minus 2, this is 3 minus 2 and this is 3 minus 5. 1 is equal to, this is b times of 1 into this value is minus 2. 1 is equal to minus 2b. So b value is equal to minus 1 by 2. And after getting the b value, now I need the value of c. So I'll keep z is equal to 5. Now see, put z is equal to, put z is equal to this time 5. So this will become 0 and this will become 0. What remains? So 1 is equal to c times of 5 minus 2. This is 5 minus 2 and this is 5 minus 3. And 1 is equal to c times of 3 and this value is 2. 1 is equal to 6c. C value is equal to 1 by 6. So these are A, B, C values. So after getting A, B, C values, now we have to substitute in this equation. So y of z by z is equal to, see here, y of z by z is equal to a by z minus 2 plus b by z minus 3 plus c by this is z minus 5. Z minus 5. In this equation, if I substitute all the values, that is y of z by z is equal to a by z minus 2 plus b by z minus 3 plus c by z minus 5. And what is our A value? A value is nothing but 1 by 3. B value is nothing but minus half. And C value is nothing but 1 by 6. From these values, if I substitute and see, if I send this z to other side, so what happens? Y of z by z is equal to 1 by 3 times of z by z minus 2. And here this is minus 1 by 2 times of z by z minus 3. And this is 1 by 6 times of z by z minus 5. And now apply, now this time we have to apply inverse z transforms on both sides. Apply z inverse on both sides. After applying z inverse on both sides, see what happens. So throughout the equation, y of z is equal to 1 by 3 times of z by z minus 2. And this is minus half times of z by z minus 3 plus 1 by 6 times of z by z minus 5. So I am applying z inverse. So this is z inverse on both sides. So this is z inverse on both sides. Z inverse, and here also z inverse. For this equation, if I apply z inverse throughout the equation, so we have a special function here, that is, according to our formula, z inverse of z by z minus a can be written as a power n. So here, according to our question, so what is the solution here? According to our solution, z inverse, so z inverse of y of z is equal to 1 by 3 times of, this is 2 power n minus 3 power n, this is minus, this is 5 power n, this is 1 by plus 1 by 6, and this is minus half. And see here, 1 by 3 times of, this is a power n, here in place of a we have 2, and here minus half times of, this is 3 power n, and here 1 by 6 times of, this is 5 power n. Here the notation in the function in the given question is k, and therefore according to our question I am writing this as k. And this is how we have to solve. And thank you so much for watching. This is also so simple if you follow these steps. So we have to consider all these conditions, and we have to apply z transforms on both sides. And after applying z transforms, we have to apply the conditions here, and we have to take y of z common, and we have to send this term to other side, and we have to send z to this side. And after resolving into partial fractions, we need the values of a, b and c. And after resolving into partial fractions, we got a value as 1 by 3, b value as minus half, and c value is 1 by 6. And after substituting a, b, c values, we have to apply z inverse on both sides. And using the special functions, we have to write according to our formula as 2 power k, 3 power k, and 5 power k. And this will be the answer. Thank you so much for following this video. And if you really like, please go through my next video, which is uploaded very soon, and share it with your friends. Thank you so much.